processing, this is one of the major steps of data mining, what has to be done before data mining. So normally data mining consists of a set of algorithms which are used in order to mine data and get patterns out of it. So this is a collection of very intelligent algorithms which have been designed by researchers. And normally when we think of data mining, we only think of these algorithms. But generally, a lot of work needs to be done before we can apply these algorithms. And there's a lot of work that has to be done after we apply the algorithms, which includes visualization of the patterns and so on. But normally we think that this middle part of the work, which is actually applying the algorithms, is the major portion. But it turns out that these remaining parts is actually 90% of the work of typical application. So only 10% of the work consists in actually applying the algorithms. 90% of the work goes into doing data pre-processing and the post-data mining tasks, which is visualization. So what is data pre-processing? Data pre-processing is actually preparing the data in a particular way into a format that is suitable for actually doing the data mining algorithms. So data pre-processing generally consists of several steps. Sometimes data is not always present in a single place. It might have to be gathered from lots of different places. For example, if you are doing some web application, so the data might have to be gathered from several different websites and collected into one single format before you can actually do data mining. Or in a business scenario, if you are the owner of, let's say, a chain of, let's say, supermarkets or some other kind of stores, then you have branches all over the city or in several different cities. In each branch, you might have a separate database which stores the data of that branch. And what you need is to collect all this data into a single location. So what you need is data gathering or data collection from multiple different sources into a single repository. And that sometimes they call as data warehousing. Okay, so where you collect data from lots of different places, clean the data. So after you gather the data, you have to clean the data. Now, cleaning sounds like a very mundane kind of work that, it's not very pleasant kind of work. But actually, lots of researchers have actually focused on data cleaning aspects, and they've developed some nice algorithms which can do data cleaning automatically. Okay, so it's not actually a very manual intensive job. Okay, so of course there is still some manual effort, but there are lots of tools that help you to do the data cleaning automatically. Okay, so once you do data gathering and cleaning, you have to convert the data into a suitable format. And the format that you need to convert it into depends on what kind of data mining algorithms you want to apply after that. Okay, so depending on whether you want to do association rules or classification or clustering, you need to convert the available data into suitable format. So for that, you might want to ignore certain aspects of the data, certain attributes. You might want to include only certain attributes. You might want to combine certain attributes into other attributes and then use the resulting format as input to the data mining algorithms. And finally, you also need to do what is called as normalization. Normalization consists of making the data into it's a kind of averaging of all the data into a uniform range. Okay, so for example, suppose you have some attribute which is having a range between let's say 0 and 1 million. Okay, and you might think that this range is too large. Okay, so you might want to normalize all the values that occur for this attribute into the range, let's say 0 to 1. So there will be fractional values between 0 and 1. Okay, so in order to do that, obviously in this case it's very simple. You just need to divide each of the available values by 1 million, and then you will get the corresponding fractional values. But in other cases, data normalization might be a little more tricky. Things like, for example, in some applications, for example, think of a scenario where, let's say, you're the judge of some music competition, okay, and students or the participants are singing different songs, and you're not a really very highly musical expert, but you can actually evaluate the music and judge whether it's good or not. So let's say the first participant comes and sings, okay, and since you have no baseline in your mind, you don't know what score to give him. You have to give him a score between, let's say, 0 and 10, and you don't know what score to give him because this is the first person who has sang. So let's say you kind of be lenient and you give him a score of 8. Okay, so then the next person comes and sings, and maybe he sings better than the previous person. So you have to give a higher score than this. So let's say you give him 9. Next person comes, he sings even better. So you, let's say, give him 9.5. Okay, so like this, and the next person who comes, maybe he sings poorer than this person, so you give him 7. Okay, so in that way, you keep giving scores to all the different people. So you have a collection of data like this, but this data is not very clean data. It's not a data that is that has been thought about nicely, because here it doesn't mean that this person sang exactly 1 unit better than this person and this person sang 1 unit less than this person. All that you had psychologically was this person sang a little bit less and this person sang a little bit better than this person. So once you have this data, you will need to do some kind of processing on this data to make sure that it's all well normalized. For example, suppose the person who had the worst score here was 5. So then one nice thing to do would be to normalize all these different values into a range between 0 and 1. And so for that, maybe you want to subtract each of these values by 5. So subtract this by 5, subtract each of these things by 5, because 5 is the minimum value here. And then once you get the corresponding values, you divide those values by the maximum value that you get, so that you get everything between a range between 0 and 1. So these kinds of things that you do is called normalization, to bring all the data into common format. So these are the kinds of tasks that you need to do for data pre-processing, and this is an essential prerequisite for actually applying intelligent data mining algorithms.